sure that you understand all the definitions appearing in videos or in the lecture notes.
I thought I understand.
Yeah, but as we see in there, like with a lot of people, like they just ignore the definition and just
Yes, that is the problem. I thought I understood it, but in the quiz, I found that I don't. So how can I solve this problem?
So maybe like you can ask yourself, like you can write down. Okay, so what are the notions? Like for the last time you have notion of upper bound.
So should I memorize the definition?
You should. You should. This upper bound. You should. There's like clear things that the teacher will use like a definition in the video. Whenever you see these, you need to memorize it. So like you can write down these words like upper bound. They say like blah 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 upper bound blah 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 blah, or this upper bound, or something like this upper bound property.
我以为贝多芬只有文组才需要。
数学是文科啊。
I don't know how to explain that in English.
But yeah, so
It's a real problem.
but I think it's not like we memorize. Oh, like you see upper bound, so it's like down and from upper, like upper side. So it's like clear to say something like if I say A is an upper bound of S, it's clear that okay, so you're thinking about like there's S and A somewhere here. After you have this kind of image, and you'll write down something like or S in S, A arguably S. And least upper bound is like easy to get because it is upper bound and it's the lowest one. So it has to satisfy two conditions. One is upper bound, and second is like you can set it either way. Like O upper bound is larger equal to this least upper bound, or average anything like is below it is not an upper bound. So, like, try to memorize them like in this way, so that you can understand what one is coming. But I think it only works here. But like, you will see topology 2 weeks later, and you need to like some kind of just memorize it. The reason why it's defined that way, you'll see it like several weeks after 2 weeks later. It will like say maybe after midterm. But yeah, we need to use those terms like repeatedly in the following sections. So yeah, I think you need to just try to treat it as your like history. Yeah. Or anything like geography, you just memorize. Okay, this is the first one. And the second one is try to make some example yourself. So after you see SUB in, the next thing you can think about is like, okay, just take some examples. So if I know like the SUB of maybe let's say what was the SUB of it? Just ask yourself a question like this. So that you can answer the second question. Usually you can answer the second question. We ask something about this, right? We ask you about like how to calculate SUB and in. We ask about what is the first. I think we asked about some intersection unions. So after you see something like this, you ask yourself if there's any example you can come up with. And the third step is to do all the exercise. I mean, like, the routine exercise I've selected is one, and the second is the exercises the teacher has stated in the video. And I think if like you go to all of this, you can get high score.
What do you mean by go through all?
I mean, go through definitions, go through this example, try to make up some examples, and do the exercises on routing I have selected, and also the problem that.
Yeah, but what do you mean by do the exercise? I can copy the solution.
Yeah, but you know, like, if you copy that, you don't learn anything. Like, if you have any question.
No, I copy all of my other homeworks, and that's no problem, right?
That's no problem, but you don't learn. You don't learn.
That's the problem. I mean, in all other subjects, copying the solution actually learn.
I'm not so sure if that's true, but yeah, in math, copying is like something like destroying your learning.
That's something that you have to explain to everybody.
How do I explain that? So math is something like mental work, and it is asks you to like do some magic sometimes. So if you can come up with those magic tricks, like if you see someone else do it, it's not magic. Right? You don't go through that tough mental work yourself.
So what is the tough mental work that's required? That's the problem.
Just like stop copying and try to figure out how to solve the question by yourself. And if you have any questions, just come to office hour and we can discuss.
But that's the whole point. When I see the question, I can't solve it.
Okay, so the step is like just as I stated, like maybe 3 weeks ago. So the first step is try to understand what you need to prove. So write down the definitions of the proposition, and try to think about like Chinese.
Don't worry, that's okay. That's okay. That's not a problem.
I'm not awake.
No, it just shows that you're bilingual. That's no problem.
So think about. I think about the definitions and think about like how to get things. Let me do this simple.
Yeah, you might need to show us an example using a sample homework question. Or like the quiz question last time.
Yeah. So this time we need to show this one. So you may come up with like, okay, so what is int e? If I say something like a equals to int e, it means that one for all s in e, s is larger or equal to a, and the second one is for all a from larger or equal to a, there exists an s in e such that s is lower than a prime. And what do I mean by a equals to negative soup of e? What do I mean by this? We're thinking about this one, right? Things soup here, so maybe you're thinking about like, what do you mean by negative a equals to soup negative e? So after you come up with this, you can write down those definitions. For all s being negative e, s is smaller or equal to negative
second one is for all A prime is for all, I would say negative A prime is smaller or equal to negative A. It exists as in E, negative E. I would say negative S, alright. So that would be F or S in E negative S. S in E negative S is larger than A. It's just definitions.
Wait, yeah, okay, so writing this down, I'm confused. So you think this is just copying the definition, but if I memorize the definition, it's not like this, right?
That's the definition.
No, I know, but I mean, that is something that if I'm the first time, I have to learn.
Yeah, I'll try it.
And you, when you erase everything, it's like magic, right?
No, it's not magic. Okay, now this one is now. Oh, sorry. Now this one. Now this one is. Now this one is definition.
Wait, how many agree this is the definition?
Now this one is definition.
Can you understand how to translate the equation to this definition? Because this is a very important part of what the TA thinks is natural, but what most normal people do not.
Sorry, it should be here. Maybe don't say that. Maybe the typo. Would you agree this one is definition? If you're confused, just tell me. This one's these two are the definition of A equals to E. And now you're thinking this is just here, here. Sorry, it should be A prime. So there's no here. Oh. Okay, so I think now you can see that these two are, I just interchange these A into negative A.
Well, why can I interchange? I think that's part of the important magic.
What's I can interchange? You mean like I'm not so sure why I have to explain.
Or let's vote. How many of you think that you can interchange? Nobody.
How about the opposite? It may just like think about like not raising their hand anyway.
See? That's the problem. I mean, for you, this is second nature, right? But why is that?
Why is okay, now it's my confusing.
Okay, let me try. I mean, yeah, I purposely think this office hour is meant to be hilarious, but yeah, that's part of the point, because for people for people who know it, there's a curse of knowledge that you don't understand why other people don't understand. So okay, so the first question is so where does this definition of the int come from? That's the first question. And if you open up your textbook, can you find this statement? Yes or no? Yes or no? Yes? How many think it's yes? Okay, some of you. How many think no? You cannot find this definition in the textbook. Okay, so at least no. So you can't find it.
I think they only define something.
But in this, let's just do it reversely.
Yeah, but that's fine. But I mean, that's part of the problem. We need to go back to the most lowest level. I mean, this is assembly language, right? I mean,
So maybe there's no if, there's only soup.
Oh, okay. So maybe that's the problem, right? So all right. So we should start out with. So what does it mean to be soup, right? And so the definition for this, you should be able to copy and paste from a textbook, right? So who can come up and copy paste the definition from the textbook? Yeah, so somebody said it's only soup, so yeah, it's your job. So you know, hey, you're tricking me. You know it. Okay, so thank you very much. So okay, so copy paste. People know how to do that, right? So there are some definitions you can directly lift out of the textbook. So that's the first step. The next thing is, okay, although the textbook might not directly define inf, but supposedly you can turn this definition into the inf by flipping it. So the question is, where are these things flipped? So, or what is the difference between this definition that you can copy paste from the textbook versus this definition? That's why we need so many different colors. I love this. Okay, so this part is different, right? What else is different? This part is is S is greater or equal to A, but here is A is greater or equal to S, right? What else? And then for the other A primes, it has to be smaller than A. This is greater than A over here. And then S is greater than A prime and S is smaller than A. And okay, so first you have to see the differences between these two, but then you have to understand why you need these differences. For the soup is the least upper bound, but the inf is the greatest lower bound. And so when we were talking about the lower bound, instead of upper bound, then your A has to be the lower bound over here, but the upper bound over here, and it has to release. So yeah, so that's why at the least upper bound here, you have to find that everything else is not the least. So there is some S that's greater than A prime, and over here it's the greatest lower bound. So for everything else, A prime, you have to find somebody that's to show that it's not the greatest. It's not the greatest. Okay, so there are things. So moving from here to here is second nature for TA or for the people who know it. But if this is the first time, then you really have to think very carefully and figure out why this is defined in the same way as this. And in a textbook, it could be only just one line saying, oh, it's obvious that you can define inf just like how you define soup. But you should try to write this down yourself. The next thing is that there is one very interesting trick here. Okay, so this definition over here, how is this related to this definition over here? Can you realize that this definition is exactly the same as that definition? So let's don't call it A, let's call it the red box. Where are the red box? Here, right? And then here. What else? Nothing else. And then we don't have the E, let's call it the yellow box. The yellow box is over here and over here. So when you read out A is the soup of E, this is the original definition, but you can recall this. So the red box is the soup of the yellow box. And so you just put in for all S in the yellow box, the red box is greater or equal to that element. And then for all A prime that's smaller than the red box, there is another element that's in the yellow box that's greater than A prime. And then what you can do is you can replace all of the red boxes with something else. In this case, RTA replaced in all of the red boxes with minus A. Although here, A was minus A. This is second nature for people who know how to do the magic. But it's not for somebody who if you're doing this for the first time. Or let me ask you, how many of you learned how to do this in high school? Nobody. Okay, the TA, okay. How many of you learned how to do this in college? See?
Okay, that's my phone.
Yeah, but this is very important. So part of 50% of the magic comes from replacing what's in the red box. So you write down the definition. This is copy paste from a textbook, but then you say, wait a minute. These are red boxes that I can replace with any element. So what should I do? I should just replace it with minus A. And so you get this crazy thing that conceptually is the same definition as what you just lifted out from a textbook. But instead of talking about A, it's talking about minus A. And similarly, well, because this definition, you can replace anything in the yellow box. This can be the set of D, or the set of Z, or a set of Wang Daoyi, or a set of Zheng Zhuanghong. I mean, you can put anything in here. And so what this definition over here is trying to do is say, let's try to define minus A to be a soup minus E. So instead of putting E, that was in the definition here, here we're trying to plug in the yellow box minus E. And so you have this very crazy statement over here that is, in principle, the exact same thing as the definition over here. But it has all these crazy minus signs that you're confused about. If you are really worried, if you do this for the first time, what you try to do is truly do this step by step. So what do I mean? So you write down this definition, right? This is copied from a textbook. Now, so you find the red box and the yellow box. So now what should you do? You should rewrite this definition. But with the yellow box and the red box. Oops. Red box here. red box. Yellow box. Such that S greater than A. Okay, so if you can't jump from this definition directly to that definition, write it down first like that. And say, okay, can I agree to myself that this definition and this definition are exactly the same thing? And if you think, no, I'm still not that sure, try again. Instead of putting the yellow box in the red box, put in Zheng Zhonghong or Wang Daoyi, right? And try to do this as many times as required until you're really comfortable that these notations, or what's in the yellow box and what's in the red box, can be anything. That's 50% of the magic. And then, after that, then you say, okay, so since I agree to myself that I'm convinced by myself that the yellow boxes can be anything, the red box can be anything, so now let's just put in, so this anything includes minus A for the red boxes and minus E for the yellow boxes. So you get to this thing. And so you realize, oh, okay, so now I can agree that this thing is the same as this thing. And you will realize that 50% of the TA's magic comes from doing the exact same thing this, like 10 times. by replacing what's replaceable with something else. If you're really not convinced, try to do this on your own iPad with good notes, where you can literally copy and then paste the whole thing, and then just erase circle out the yellow boxes, red boxes, and start to replace. Yeah, this is a very low level assembly language level technique that's in the DNA for most of the TAs, including myself. But this is something that is magic to normal people. And so, at some sense, 50% of the magic comes from doing the exact same thing, replacing these red boxes and yellow boxes, starting from a definition, going step by step, and then all the way to, you finally get to a statement that, that's the answer. But, but if you don't know how to go from this definition that's on the textbook directly to this definition that the TA just wrote down like it's natural, that does not mean you understand the definition. That's the problem. So when we say you need to understand, you need to truly remember or understand by heart the definition. That's what it means. And in fact, I can give you, actually, if you look at any of the questions, when you say start from one step and write down a definition, then it's like that. And then you start to carve out the boxes that you want to replace, and then keep doing replacements until somehow the answer comes out. Yeah. But without knowing this magic, then you're lost 50% of the time.
Okay, so maybe I'll keep doing this. Like you want to connect these two, right? So you're just.
So going from here, so the definition of soup or least upper bound is over here, and then we carve out that, and so we get, so by definition, this statement means this thing. This comes directly from the definition, but there's this hidden replacement of boxes over here that's there. And then, okay, wait, I think we need to circle this out. Yeah, okay, so the question is to show that this equals to this, right? So the first step is to say, what does this mean? And so to say that minus A equals to sup minus E, then we draw from a definition to get this thing. So that's 50% of the magic. So trying to go to give the definition of sup minus E. And then the next part of the magic is to say, how can I show you that this statement coming from the definition of sup is actually equivalent to this definition, which is the definition for in. And then I'm done. So there are two parts of the magic. One is to carve out the definition, or to spell out the definition. So the definition for in is over here, is this statement over here, and then the definition for sup is this definition over here. And this thing comes from this crazy transformation, replacement of boxes that you need to know by heart. That's half of the job. The other half is to say, why does this statement is the same as this statement? And yeah, that's the second half of the magic that the TA will want to show. But before I go on, I do want to make sure that you understand that. So there are two parts of the dark magic, and one is translating or spelling out the definition, and that's replaceable to be anything. If you don't believe me, put your name in these boxes. Put your name and my name in these boxes and write the definition again. Convince yourself that, yeah, so Wang Daoyi is the sup of Zheng Zhonghong. Means what? And then you can put in your favorite, yeah, right? Zhang Yuchen is the sup of Taiwan Dui or whatever. Or anything, and then spell it out. Make sure that you can replace these boxes with anything. That's 50% of the magic. Yeah. And then you can say, okay, so the next job is, why does this spell out of the definition of in equals to this spell out of the definition of sup? And that's the other half of the magic that the TA is gonna show.
We want to connect these two, right? So you just want to make the negative E here to E here so that we can compare. And remember that negative E is just like E and negative. So we just like do E here and put a negative here to come up with this. Is that part of magic to you? I'm not so sure what is magic, what is not.
Yeah, so how does this line equal to this line? Yeah, so there are some.
How about we do this? So negative S.
No. Don't change the lines.
Okay.
You need to write another line. No, you need some intermediate step for the.
Okay, so we'll first do this, okay? Go with C, negative here. So we want to put a negative before S, so that we have this line. Any problem for this step? I just want to like, because here's negative, so I put negative here.
Okay, so how does this line become that line? Actually, it's the same dark magic that I just showed you. So this S, this is for OS in the yellow box. this blue circle is less or equal to the red box, right? So I can replace this, what's in the red circle, oh, sorry, blue circle, with anything I want. Or, so for all blue circle, whatever's in the blue circle, in the minus E, the blue circle is less or equal to minus A. So this line is the same as this line. And again, if you're not convinced yourself, put in whatever things that's in the blue circle, right? Put in pizza. So all pizza in belongs to minus E. Pizza is less or equal to minus A. Put in, I don't know, 蛋饼 or put anything. And once you're convinced, you should realize that, so if I can put anything in the blue circle, then I can put in even minus S. So these two things are exactly the same thing.
And why I want to put that thing here is because I want to like correspond to negative here. Okay, so just stare at it.
And given this, so okay.
So because negative S is in negative E, which means that you can write down
S is in E.
So negative S, negative A. This one is just A is larger or equal to S.
Okay, so the red line is more standard. I think you learned the red line in high school, right? If minus S is less or equal to minus A.
Sorry,
That's what yeah. So you can move the minus A to the left hand side and the S minus S to the right hand side to get this one. So this part this part of the magic you know in high school. But this part, is it okay? If minus S is in minus E, then S is in E. Is that okay? Think carefully. Okay, I do want to make this very explicit because this is all of the unpacking of the dark magic. Wait, so what does minus S is in minus E mean? Or what does S is in E mean? So this is a definition from of a set or an element in a set, right? So this E is so you define a set E where so you can find an element of S that's in E. The question is how do you define minus E? What does minus E mean? Okay, so now we again need to unpack this dark magic. So minus E is a set where
S as in E.
let's have another location. So what's your favorite element? Let's just put T, whatever. T is in
T is in E.
So it's all of the T that minus T is in E. That's the definition for minus E. So if E is the set of, say, 1, 3, 5, 7, minus E would be minus 1, minus 3, minus 5, minus 7. Because if for minus 1, minus 1 is 1, that's in E, and minus 3 is 3, that's also in E, and minus 5 is also in E, minus 7 is also. So that's how you define minus E. But what this means is that if any element is in minus E, then it's minus that element is in minus E. So this line is the same as this line. I see everybody confused. Yeah. So, I'm a little bit hesitant here to go into that part because supposedly you guys know this from high school. What is a set and the definition of a set, but maybe not. So if you don't understand that part, then you really need to go back to your high school textbook and find out what's going on, or maybe I should try to find the right textbook chapter, because I don't think Rudin talks about set theory, right?
Rudin.
No.
No.
Okay, so I will have to find the corresponding parts that talks about set theory. Yeah. So it's a little bit challenging to talk about this.
I don't remember any good talk about sets.
Yeah. Anyway, so the key thing here, so what I'm showing you here is that here I'm using the same dark magic and the same 50% of the dark magic of unpacking the definition. But then the other part of the dark magic is to try to manipulate these equations to make it look more and more like what you get on, or what you hope to get on the other side. So that's why I say that there are two parts of the magic. One is to unpack the definition and start to replace all of these red boxes, yellow boxes, just to whatever you want. That's one part of the magic. The other part of the magic is to say, okay, so now I got this definition, how can I move these elements around and eventually get to this part of, and so the second half of the dark magic should be more easier to you because you learn how to move these parts of the equation to the left hand side or to the right hand side and all that in high school. But what you have never really tried is how to move it in a meaningful way so that you can achieve your final destination. So it's like you know how to drive, but you don't have Google Map to tell you how to drive or to which direction you should drive. If you don't have Google Map, then you should just try different directions and find, now I know how to go from here to here. If you're really lost, then maybe Google Map can help you. But the danger is the following. If you only know how to drive with Google Map, then what would happen? If you only know how to drive with Google Map, then when there's no internet, then you're lost. And that actually is the main problem for learning mathematics, which is, if there is a Google Map, if there is the TA or the solution that shows you the right direction, then you can follow it. But the real challenge is when you cannot use Google Map, then how can you find your way yourself? And at some sense, it's more like a trial and error process that that after trying 5 hours on one question, then you start to have a sense of, oh, okay, so maybe going north is the right way, and you try to figure out. Yeah. You have a question? Okay. Yeah. So and that is the part you need to spend time on, because unpacking is like copy paste from the textbook. Replacing, well, you might need to rewrite the definition several times to get used to this is the same as saying this, as the same as saying this, and so on. But that's the easy part. The last part is to say, going from this to this, well, what is the right route, and without Google Maps.
I think like for the routing problem, it's natural for you to stuck on it for like 3 to 5 or more hours. So just like don't be like frustrated if you cannot find it in a very short time. Just try it and just try and everything. So
Actually, that's one of the reasons why I don't like routing, because
yeah, I don't like routing either. I like other books. Maybe I can recommend it like
no. Yeah, so the problem for routing is that it only gives you the most difficult questions that you take so long.
And in routing, like it don't explain the proofs in this way. It just magic, and it's like more magical than we have illustrated here.
Yeah.
Okay, so maybe because of time, I need to wrap up this. So as you can see that this one is exactly the same as this one. So we have done. The second part, okay, you can figure it out by yourself. If you have difficulty on this, we can discuss it on office hour. But because of time, I need to move to the review part. I think you have encountered complex numbers in your high school, so I just skipped most of the thing. I talk about okay. Do I need to go to triangle inequality? No, so Cauchy only. They're saying T or not T? I forgot. I think no T. Schwartz. It'd be like like this one, right? For well, I will write it in this way. For A, B, in some, take a VOC. And I think in video, it's just first discuss about how to do with Rn, and then we just move on to Cn. I'll add a part here. I'll just show R2, right?
You raised that.
Ah!
That's okay.
No, I need a photo of that.
You can like do the Photoshop, do the steps.
Yeah.
Do the steps, right? Okay, so the first part. Let's think about R2 first, alright? R is too difficult. Like, you see the magic here. A1x minus B1, blah, 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 blah. How about we just do R2?
So we're thinking about,
And so it's greater or equal, right?
oh, sorry, where is it? B1 squared plus B2 squared as larger or equal to A1, B1 plus A2, B2 squared. You're trying to prove this thing. You want to show this, right? And I think the easy way to do it is just try to do this kind of thing. Plus A2 squared B1 squared plus A1 squared B2 squared plus A2 squared B2 squared. It's larger or equal to A1 squared B1 squared plus 2A1 B1 A2 B2 plus A2 squared B2 squared. As you're trying to prove that A1 squared B1 squared, sorry, A2 squared, A2 squared B1 squared minus 2A1 B1 A2 B2 plus A1 squared B2 squared is larger or equal than 0. Just move everything to a side. This gives you A2 B1 minus A1 B2 squared larger or equal to 0, which is true. And why I want to go through this is I want to tell you that actually this equation, or there's at least inequality, gives you some kind of quadratic sense. So you can see we're doing something with quadratic equation things here. And having this kind of sense, turn back to see this original inequality that we stated in Rn. Or I'm not saying that they're exactly the same, but I just want to show that there is some quadratic feeling that you can use. The second part. So observe this thing. You can try to think about like, okay, so there's AI here. There's some BI here. And there's AI BI here. Remember that we have something like multiply things when we're doing quadratic. So maybe you're now thinking about something like AI minus BI thing. So after you got this kind of feeling, the thing in the video is not that magical. It's just considering, maybe it's still, it's just consider sum of this one. And you know the determinant is less or equal to 0 because and then just calculate D. D means I use different color. D means B squared minus 4AC. So D here is less than or equal to 0. Right.
that'll be 4 AI BI is 4 AI BI square. That's minus 4 AI square BI square is that's all equal to 0. We almost done the proof. We'll start our test maybe on 30, or I cannot finish this. So this part is for RN, right? And thinking about this quadratic thing, you're actually saying that you're taking what? Taking x to negative. That's how you do the experiment in I think junior high. So how to find an experiment of an quadratic equation is that you let x equals to this one. And what is the negative 2a over b here in this? I'll write it down. It's just like bi square x square plus that's a negative 2 ai bix. Alright, so that's negative 2 and plus ai squared. So here it would be negative 2 times negative bi squared and negative 2 sum over ai bi. So it would be BB A B. Okay. This observation is same. Take it in this way. So if you put this one back here, you'll get the same thing that this equation tells you. I just plug the things in, okay? If we plug these things in, you get to BB, AB, and here's BB squared plus negative 2 AB BB and plus BB plus AA. I'm right.
Wait, hold on. Your A.
Oh,
your
BB
A-
square,
your-
BB square, BB square, BB square.
No, the question is
A square.
your x, if your x is this ratio, then where is your x squared?
Let me check. Also read like.
Yeah,
this
and
one.
then the BB itself is itself.
BB sub is itself. BB sub is
And so there's no square there.
yeah.
Check if it is correct.
itself. Check. Yeah, I think I'm correct. Plug in this one.
Okay. So it gives you AB square over BB minus AB square over 2 times 2 and plus AA. And you know that this one is larger or equal to 0. Right. And again, we do this one. This one equals to AA minus AB over BB. So this one larger or equal to 0 squared just gives you the thing you have there. Right? So just AB, AA, just give you this one. AB is larger or equal to AB squared. AB squared. It's just observation from this one. And I think there's a proof, like in the video. Okay, so the third part is for CN. I'm trying to do square here because I want to make sure the length, right? And so that we have this one. And in complex, we know that we need to put it in some conjugate way, right? So the first one would be like AI minus BIX sum over BIX. Be something like this. I think it's the same thing if you see here. The negative thing, the square thing is like taking the inner product of itself in reals. Right. And what this gives you? It gives you sum of AI sum of AI. Check it. Correct. I should put it. So I think I should put it sigma here. Correct. Yeah, I'm correct. Sorry, you should be doing it this way. Well, AI. Is sigma AI minus sigma BIX. Sorry, let me check. It should what? It should be kicking this one out. AI here, BI here, BI. Okay, so sorry. The original version is correct. It should be this one. Sorry for the confusion. I'm
I mean this one. Sigma AI minus BIX. AI minus BIX. So what do we mean by this term? We mean by, okay, so here is AI minus BIX and times minus BIX. Right. So you're taking sum over AI bar minus BI, AI bar BIX minus AI BI bar X bar plus BI bar X bar. Okay? Cool for you? And remember that what we do need this observation, so that BBAB will be here, right? So again, we're writing this one in a projective, in a product sense. We change it to AI, minus, it will be BI X minus AI BI X bar plus BI and X. So we can take X in that way, okay? Take X in BB. Sum over BB. Let's do this. I first do this and I take that one. It just sum over AI, the square of the sum over it, so it's just AA and minus B A X minus A B X bar plus B X and take X equals to B A B. And why we taking this but not BA is because that we want to make this term and this term to be real. So that we know AB times BA equals to, so we know BA equals to AB conjugate. And this one's real. So this term becomes real. And this term becomes real. Alright. Okay, follow me? Cool. So if we plug in those things, okay, cool. That will gives you AA and BA, AB, so that would be minus A B square BB and minus
And you know that this one, because from this, you know that it's logically equal to 0. Right? Because this one is sum over AI minus BIX. So you know this one is larger or equal to 0. So you know this one is larger or equal to 0. And just do the switching and the previous one. The next thing you should remember for the induction is you need to know the well ordering principle, and you need to know how to do the induction. Any question about well ordering principle or induction? If not, just skip it. Or I'll do one side I'll do both sides. Okay, and we'll start our quiz at 40 and you'll take that to 30. And maybe we cannot finish the talking about the explaining the quiz, but yeah, that gives you enough time to answer the question. I'll do both sides. So there's two notions. One is WOP, and one is what I call we use induction or induction principle or
Principle of induction.
principle of induction, or say PI here. And what is WOP? That is for all as and we know that if S is not empty, then as the least element, and BI means that if S is not S, and we know one is in S, and the second is K in S ensures that K plus 1 in S, then S equals to M. And actually, the WOP with PI. I think he did this way, right? He did. Which way is it?
Well, order equality to the production of induction.
This one?
And
Okay, so suppose we have PI. We need to get WOP. Right. Another slide? So suppose we have WOP and want to prove PI. Okay, so let us think about this. How can it, if not, okay, we'll do it by contradiction. Suppose S is not equal to N, which means that N minus S is not empty. By WOP has the least element. Let's say little n. Alright? Any problem for this step? It's contradiction. We're thinking about like how to prove the PI. How to prove the PI. So saying that because it has least element, we're saying that we're thinking about like something. If it is not true,
then there's a least element that doesn't satisfy this condition, so then maybe normalizing to S. But what? But we know n is not 1, right? Because 1 is in S. And so n minus 1 in N, and also n minus 1 in S. Because the least element for this one is n. So n minus 1 is not in, so n minus 1 is not in this one. Okay. I'll be right. Which means that n minus 1 doesn't lies on this. So either way, one is n minus 1 doesn't belong to n, or n minus 1 belongs to S. Either we know n is not 1 because 1 is in S. So n minus 1 is in n. So n minus 1 is in n. So it must be like n minus 1 is in S. But by 2, we know n in S. So there's contradiction. Alright, the other side is similar. Other side. So we're saying that if this one holds, right, then any set is not empty, has a least element. So let us thinking about like, okay, if there's any set that has no least element, that has let's so have here has no least element. So the first one is that 1 does not lie in S, which means that 1 lies in n minus S. And the second one is suppose K does not in S, we'll use strong induction here, right? Say 1 to K does not, it's not in S. Then K plus 1 cannot be in S. Or there's a least element, right? So we know that K plus 1 is in n minus S, which means that n minus S equals to n. S equals to the empty set, the previous law. I think the strong induction is allowed when you're doing quiz. Yep. Okay, we'll start the quiz